This is the fourth sample problem dealing with probability. In the previous problems, we've been considering one trait at a time. Now we're going to take it a little bit more complicated step. I have two parents. These parents have multiple traits. 1, 2, 3 total traits. The A trait, the B trait, and the C trait. I want to figure out what the probability is of a child who has a very particular genotype based on these two parents. Now, chromosomes sort independent of one another. So whether you get a big A going into a gamete has no effect on what kind of letter B you have going into a gamete. It's equally likely that you could get either of the two possible alleles. The events are independent of one another. Therefore, in order to figure out the total probability of ending up with a particular child, that total probability is equal to a multiplication of the probabilities of each independent trait. So we'll take the probability of the desired A trait. So lowercase a, probability. And we'll multiply that by the desired genotype for the B's, by big B, little b, probability, multiplied by the probability of ending up with that heterozygous Z combination. This product will give us the total probability for the desired offspring. So let's set up some squares and see what the results of this are. Let's consider the probability of each trait separately. For the A's, what am I crossing? The two parents have, one parent has heterozygous for the A trait, the other parent has heterozygous for the A trait. So when I go through, I'm going to put one parent's gametes down the side, the other parent's gametes across the top, and solve my cross. Let's go through and do this for the B's and C's as well before we come up with our probabilities. For the B's, one parent is homozygous dominant, the other parent is homozygous recessive. One parent's gametes go down the side of my box, the other parent's gametes go across the top, each gamete getting its own row or its own column. And then I solve my cross. Let's do the same thing for the C trait. We're doing these separately because each trait sorts independent of one another. The results of the B crossing and how the B's segregate to make my different gametes are completely independent of how the A's or the C's cross. For the C's, one parent is homozygous recessive, the other parent is heterozygous. One parent down the side, the other parent across the top. Solve your cross. Be careful with C's because capital and lowercase look so similar. Make sure that you don't get confused here, that your handwriting is neat. Now, let's look for my desired outcomes. For the trait A, I want homozygous recessive. Look in your boxes and indicate how many of those boxes are homozygous recessive. There it is. So I have a 1/4 probability of these two parents having a homozygous recessive for the trait A. Let's move on to B's. For B's, I want heterozygous. 1, 2, 3, 4. So I have a 100% probability. 100% probability in fraction form is equal to a probability of 1. Now let's consider the C's. For these two given parents, I want the heterozygous trait. Looking at my boxes, I see that 2 boxes have that heterozygous trait, which means that 1/2 of my boxes, or 2/4, will have that heterozygous outcome. That's the probability. Now I need to take the product of all of these. 1 is like having 1/1. To multiply in fractions, multiply across the numerators. 1 times 1 times 1, my numerator is 1. Then multiply out the denominators. 4 times 1 is 4, times 2 is 8. So the probability that I will end up with a child, given these two parents, whose genotype is little a, big B, big C, is 1/8. There's a 1/8 probability that these two parents will give rise to this child with this particular genotype.